In 4.6, we're going to look at what's called the product rule. And before I explain to you what the product rule says, I just want to show you by an example of what could possibly happen if you didn't know about the product rule. In the previous section, we learned that if you had the function f of x equals x squared plus x cubed, that taking the derivative was simply a matter of taking their individual derivatives. So you would just go f prime equals 2x plus 3x squared. That was our sum and difference rule. Now, having seen that, there'd be a temptation then to think that what if you had the function f of x equals x squared times x cubed? Now, having just seen the sum and difference rule, there'd be a tendency to think, well, why not just do the same thing? Why not just take the derivative of x squared and take the derivative of x cubed? So if we did that, if we went f prime of x equals, and we took the derivative of x squared, which would be 2x, times the derivative of 3x, or x cubed, which would be 3x squared, we would get the answer 6x to the 3. Now the question is that the right answer? Well, we're not sure, but what we do know is that what if we had taken the original question and multiplied them together? Since we can do that, there are laws of exponents. What if we multiplied them together? We would get f of x equals x to the 5th. Now I'm pretty confident in my ability to take the derivative. The derivative would just be 5x to the 4th. So I know this answer is right because I know x to the 5th is equivalent to this, and I know that this is how I take the derivative of a power. Now you notice that we didn't get the right answer. This is definitely the wrong answer. So the reason why I took you through this illustration is there's something very important happening here. And that is that just because you can take the derivative of a term plus a term, it doesn't mean that you can take the derivative of a term multiplied by a term. And so that leads us to what's called the product rule. The product rule is going to be a rule that allows us to deal with functions being multiplied together. So the product rule says that if you have a function f of x that's equal to a function p of x times a function q of x. Notice it's not being added. If it was being added, it would be our sum and difference rule. In this case, it's being multiplied. The derivative, f prime. Now I'm going to show you the product rule. Again, like all the rules of calculus, it's fairly simple. You just have to memorize the rule. The rule says that if you have two functions being multiplied together, what you do is you take the derivative of the first function. So you take the derivative of p of x, and then you multiply it by q of x, but you don't, without taking its derivative. So just multiply by whatever q is. You then put a plus sign, and then you just reverse the situation. You take the derivative of q, and you multiply it by p. Now again, the proof of this rule is in your textbook if it really interests you, but you're not responsible for it, so I'm just going to ask that you learn the rule and that you're able to apply it. Now I wanted to show you that in this question we did up here, let's try using the power rule and see what happens. Let's take the function f of x equals x squared times x cubed. Now according to the rule I just showed you, this power rule, what I should be able to do is I should be able to identify x squared as being p and x cubed as being q, and they're being multiplied. So according to the product rule, my derivative f prime should be the derivative of p, which would just be 2x, multiplied by q, which would be x cubed, plus, I now take the derivative of q, so q being the x cubed, and I get 3x squared times p, which is x squared. Now notice what happens. We get 2x to the 4th plus 3x to the 4th, which is 5x to the 4th, which doesn't surprise us because we already knew that was the correct answer up here. Now this is not a proof of the product rule, but it does illustrate that the product rule works. Now you obviously wouldn't use the product rule for a question like this. You would just multiply them together. It's faster. In fact, all the examples I'm going to show you right now, we probably wouldn't use the product rule, but it's just for practice. So if I gave you something like f of x equals 2x plus 1 times x squared minus 3x. Now, if I was doing this question, I would just multiply these together. And I want you to appreciate that. This really isn't going to be a question that we're going to use the product rule for. But right now, until we've learned some of the other rules, we have to keep things pretty simple. So right now we have a product. Everything from here to here, that's 2x plus 1. Think of that as p. And everything from here to here, think of that as q. And they're being multiplied together. So we have a function multiplied by a function. So according to the product rule, to take the derivative of f prime, we would take the derivative of p. So if you look at p, it's just a polynomial, 2x plus 1. So you take the derivative of 2x, which is 2, plus the derivative of 1, which is 0. So that's p prime, multiplied by q, which is x squared minus 3x, plus, now take the derivative of q, which would be 2x minus 3. We're just using our sum and difference rule and our power rules, multiplied by p, which is 2x plus 1. Now, this could be distributed and expanded and simplified, but for now, I just want you to practice the product rule, so we'll just leave it like that. The product rule that I just showed you can be extended to any number of factors. So if we had a function f of x, and that function was equal to p of x times q of x, that would be our product rule. But what if it was being multiplied by a third function, r of x? In fact, this can be extended to any number of functions. Then, the derivative f prime, it's identical to the product rule for 2. You take the derivative of the first function, p, and you multiply it by q and r. Then you put a plus sign, and you just work your way through all the factors. You take the derivative of q, and you multiply it by p and by r, plus, and then you finish off by doing the last one. You take the derivative of r, and you multiply it by p and q. That's called the extended product rule. You won't use that very often, but if you ever did have to multiply 3 things in a row, the derivative is exactly the same as the product rule for 2, except you just repeat the process. You can see where this could be extended to any number of factors. Okay, we'll just finish off with an example. Something like, find the slope of the tangent line to y equals x squared plus 3x times x cubed minus 6x plus 1 at x equals 2. I want to finish off by just, now that you're learning these rules, you're going to notice that the rules themselves are very simple. So we need to start talking about why they're important. Like, why do we need to learn them? So what is this question really asking? Find the slope of the tangent line. Well, hopefully you understand now that the slope of a tangent line is the derivative of a function. So what this question is really asking me is to find the derivative of this function at x equals 2. What is the slope of the tangent line at 2? Well, notice that we have a product. All of this is p. All of this is q. So the first thing I need to do is take the derivative. So dy dx would equal that little vertical bar I put there. You'll see why that's there in a second. According to the product rule, I would take the derivative, which would be 2x plus 3 times the second, plus the derivative of q, which would be 3x squared minus 6 times p. Now that's my derivative. That will give me the slope of the tangent anywhere on the graph. But we want the slope of the tangent at 2. We want a specific slope. So the way we write that is we write dy dx at x equals 2. Now what you would do at this point is you would just replace all of these x's with 2's. So you would go 2 times 2 is 4. 4 plus 3 is 7. Times 2 cubed is 8. 8 plus 1 is 9. 9 minus 12 is minus 3. Plus 2 squared is 4. 4 times 3 is 12. 12 take away 6 is 6. Times 4 plus 12, 4 plus 6, which is 10. And that works out to be 39. That 39, if you actually drew this graph right here and drew the tangent at the point 2, your slope would be 39. And we found that by using our rules of differentiation, in particular the product rule. Much easier than using the limit concept.